A rare form of malignant tumor occurs in 11 children in a million, so its probability is 0.000011. Now, 4 cases of this tumor occurred in a certain town, which had 9,652 children. In Part A, assuming that this tumor occurs as usual, find the mean number of cases in groups of 9,652 children. So to find the mean number of cases per year, we multiply the number of children in the group by the probability that one of them develops a tumor during the year. So we're going to use these values to compute the mean number of cases per year, and then rounding that to 3 decimal places. So the mean is equal to the number of children times the probability of a tumor developing. So 9,652 times 0.000011 is equal to 0.106172. And if we round that to 3 decimal places, we get 0.106. So this shows the mean number of cases per year is 0.106. Now, using the mean from Part A, find the probability that the number of tumor cases in a group of 9,652 children is 0 or 1. The total probability that 0 or 1 cases will occur is the sum of the probability of 0 cases occurring and the probability of 1 case occurring. And this probability can be expressed as follows. The probability of 0 or 1 is equal to the probability of 0 plus the probability of 1, which is also equal to the probability of x being less than or equal to 1. So using StatCrunch, we're going to select Stat, highlight Calculators, and then select Poisson. In the dialog box, we're going to enter the value of the mean to be 0.106, and then we want to find the value of the probability of x to be less than or equal to 1, and then select Compute. So opening up StatCrunch, we're going to select Stat, Calculators, and then scroll all the way down to Poisson. We want to put in our mean that we found to be 0.106. And we know that we're looking for x to be less than or equal to 1, and then select Compute. And therefore, we get the following. You see that this shows, rounded to 3 decimal places, that the probability of either 0 children or 1 child developing a tumor during the year is 0.995. Now, what is the probability of more than 1 case? So what we're going to use now is the rule of complementary events, which states that the probability of an event A happening is equal to 1 minus the probability of its complement happening. If the probability of the complement is the probability that 0, 1 cases occur, then the probability of the event A must be the total probability that all other possible number of cases occur. So we're going to use the following formula. The probability of event A, which is equal to 1 minus the probability of the complement of A. Well, we're going to use this to find the probability of all but 0 or 1 cases occurring. So the probability of greater than 1 is equal to 1 minus the probability of less than or equal to 1. So that means we're going to take 1 and then subtract 0.995, which is the probability that we found in the Part B. And 1 minus 0.995 gives us 0.005. And therefore this shows the probability of more than 1 child developing a tumor during the year is 0.005. Now in Part D, it says let a probability of 0.05 or less be very small, and let a probability of 0.95 or more be very large. Does the cluster of 4 cases appear to be attributable to random chance? Why or why not? Does the cluster of 4 cases appear to be attributable to random chance, and why or why not? Well, consider the probability of more than one case appearing. We get the probability to be 0.005. That means an event with a probability of less than 0.05 is not considered to occur by chance. So therefore, because 0.005 is less than 0.05, we would say no, because the probability of more than one case is very small. In part D, it says, let a probability of 0.05 or less be very small, and let a probability of 0.95 or more be very large. Does the cluster of 4 cases appear to be attributable to random chance? Now, if we consider the probability of more than one case appearing, we found that probability to be 0.005. And that value is less than 0.05, which means it's very small. That means an event with a probability of less than 0.05 is not considered to occur by chance. So we would say no, because the probability of more than one case is very small.